Hello students, warm welcome to all of you. In this module we are going to discuss about 3 marks problems. They are long answer type questions from the chapter Polynomials. Okay, let us see what is the first problem given here. The sum of zeros of a quadratic polynomial ky square plus 2y minus 3k is equal to twice their product. Sum of the zeros is equal to twice their product. So let me take the zeros of the polynomial. For example, alpha comma beta are zeros of the polynomial ky square plus 2y minus 3k. Right? What is sum of the zeros? Alpha plus beta is equal to minus b by a, which is equal to minus b is 2 divided by a is equal to k. That is alpha plus beta. And what is alpha into beta, which is going to be c by a. So c is minus 3k divided by k. So of course k and k gets cancelled. So it would be minus 3. So alpha into beta is equal to minus 3. According to the given problem, sum of the zeros of this polynomial is equal to twice their product. Means sum of the zeros means alpha plus beta is equal to twice their product. Their product is alpha into beta. So alpha plus beta is equal to 2 into alpha beta. Right? What is alpha plus beta? That is minus 2 by k is equal to 2 times their product is equal to minus 3. Got it? So here 2 ones cancel. Minus and minus gets cancelled. So finally 1 by k is equal to 3. If 1 by k is equal to 3, therefore the value of k is going to be 3 by 1. So which is going to be 3. The value of k is equal to 1 divided by 3. Because 1 by k equal to 3, so k is equal to 1 by 3 obviously. So such a simple problem given for 3 marks. Right? So moving on to the next problem. So this problem is find the zeros of the quadratic polynomial 90 square minus 60 plus 1 and hence verify the relationship between the zeros and coefficients. So this is one of the most important compulsory question. So let us consider the given polynomial is in terms of t. So I would write that p of t, because it is in terms of t, is equal to 9t square minus 60 plus 1. So we can factorize this by splitting middle term method. See, first of all, you multiply coefficient of t square, otherwise t square determinant constant. 9t square into plus 1 is equal to plus 9t square. So now you will have to split that 90 square into 2 terms such that their product is 90 square and the sum is equal to minus 60. See here, when product is positive, when product of 2 terms equal to positive, either both of them are positives or both of them are negatives. That depends upon the sign of the middle term. See here, the middle term is sign is negative, so that both of them must be negatives. Right? So what are the factors of 9? 1 9s are 9. 1 plus 9 are minus 1 minus 9 is equal to minus 10, but it is 6. So 1 and 9 are not the factors. 3 and 3, minus 3 is equal to minus 6. Yes. So minus 3t are the factors of plus 90 square. So that I am going to write this as 90 square instead of minus 60 as minus 3t plus 1. From the first 2 terms, you can take one 3t common. Remaining 3 3s are 9, t's are t square. Minus 3t already taken common, so minus 1. And from these 2 terms, minus 1 is common, remaining 3t minus 1. So totally you have 3t minus 1 factor, and here 3t remaining, and here minus 1 is remaining. So finally, your p of t is going to be 3t minus 1 into 3t minus 1. In order to find zeros of the polynomial, let us take this polynomial is equal to 0. So in order to find zeros of the polynomial, you will have to equate the given polynomial with 0. Right? So 3t minus 1 is equal to 0. 3t is equal to 1. Then the value of t is going to be 1 by 3. So if 1t is 1 by 3, other t is also 1 by 3, right? Therefore, what are zeros of the polynomial? Zeros of the polynomial p of t is going to be let me take first 0 is alpha. Alpha is equal to 1 by 3 and the second 0 is beta. Beta is also is equal to 1 by 3. So these are zeros of the polynomial. That is the first part of the problem. And the second part, hence verify the relationship between zeros and coefficients. So it means you will have to check whether alpha plus beta is exactly equal to minus b by a or not, and alpha into beta is equal to exactly c by a or not. Before that, you will have to equate given p of t with the standard form. So given p of t is minus 6t plus 1 is equal to a t square plus bt plus c. Why am I writing in terms of t? Because our polynomial is also given in terms of t. That's it. So the value of a is equal to 9, b is equal to minus 6, c is equal to 1. So what is the first thing? First thing is sum of zeros. First thing is sum of zeros. So sum of zeros is alpha plus beta, which is equal to minus b by a or not. Alpha is equal to 1 by 3 plus beta is also equal to 1 by 3 equal to minus, what is the value of b here? B is going to be bt and this is minus 60. So minus 6 divided by a is equal to how much? A is equal to whole divided by a is equal to 9. Correct? 1 by 3 plus 1 by 3. How many 1 by 3s are there? There are 2 1 by 3s. 1 by 3 plus 1 by 3 is 2 by 3 is equal to minus of minus plus. 6 and 9 can be cancelled by 3. 3 2s are 6 and 3 3s are 9, which is equal to 2 by 3. So 2 by 3 equal to 2 by 3. So it means sum of zeros is verified. Now coming to the second one. What is the second one? That is product of zeros. Product of zeros. So product of zeros is equal to alpha into beta, which is equal to c divided by a, and the value of alpha here is 1 by 3 into beta is equal to 1 by 3, which is equal to c. What is c here? C is equal to 1 divided by a is equal to 9. So 1 by 3 into 3 is equal to 1 by 9 is equal to 1 by 9. So it means product of zeros also verified. This is what is the verification of the relationship between zeros and coefficients of the given quadratic polynomial. So sometimes you can expect this question for even 5 marks also. Right? So please remember how to find out zeros of the polynomial by splitting middle term method, as well as how to verify the relationship between zeros and coefficients. Okay? So let's move on to the next problem. If alpha and beta are zeros of the polynomial, then form a quadratic polynomial whose zeros are 2 alpha and 2 beta. These kind of problems are quite interesting. Let me take the given polynomial as p of x. So given polynomial is 4x square plus 4x plus 1. Okay? This is what is the polynomial and whose zeros are alpha and beta. So x is equal to alpha and x is equal to beta. So if I can find out one polynomial whose zeros are alpha and beta, that is exactly same as x square minus of alpha plus beta times x plus alpha into beta. Okay? And here alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. Okay? So what is the value of alpha plus beta here? Alpha plus beta is equal to minus b by a is going to be minus 4 by 4, which is equal to minus 1. And alpha into beta is going to be c divided by a, and the value of c is equal to 1 divided by 4. What do you want now? You want a quadratic polynomial whose zeros are 2 alpha and 2 beta. This is a polynomial whose zeros are alpha and beta, right? So now, whose zeros are 2 alpha and 2 beta, then for example that is g of x. I am substituting 2 alpha in the place of alpha and 2 beta in the place of beta. That is x square minus 2 alpha plus 2 beta times x plus 2 alpha into 2 beta. Okay? That is x square minus, you can take one 2 common here, then it would be alpha plus beta plus 2 into 2 is equal to 4 alpha beta. So you know the value of alpha plus beta as well as alpha beta. See here, these are the values of alpha plus beta and alpha beta. We can substitute back here. That is x square minus 2 into what is alpha plus beta is minus 1 into x plus 4 into what is alpha beta? Alpha beta is equal to 1 by 4. So finally, the quadratic equation is going to be x square minus of minus plus 2 into 1 is equal to 2x and 4 cancel plus 1. This is what is the quadratic polynomial whose zeros are 2 alpha and 2 beta. But I just wanted to give you one very much useful information here. See, suppose if this is a polynomial, p of x is equal to like ax square plus bx plus c, and alpha comma beta are zeros of this polynomial. Okay. What is the polynomial whose zeros? What is the polynomial whose zeros are multiplied by 2? What is the polynomial whose zeros are multiplied by 2? Whose zeros are divided by 2? Whose zeros are subtracted by 2? Whose zeros are added by 2? For example. Now, this is what is the polynomial. You want what is the polynomial whose zeros are 2 alpha, 2 beta. Means the polynomial whose zeros are multiplied by 2. If you want a polynomial whose zeros are multiplied by 2, then you will have to find p of x divided by 2. Because x is equal to alpha, right? Now x by 2 is equal to alpha. If x by 2 is equal to alpha, x is equal to 2 alpha, right? So if you find what is p of x by 2, then it is going to be, your polynomial is 4x square plus 4x plus 1. 4 into x square, x is x by 2 whole square, plus 4x is nothing but 4 into x by 2 plus 1. So if you simplify this, 4 into x by 2 whole square is x square by 4 plus 2 1s and 2 2s are 4, it is 2x plus 1. 4 cancel. Finally you get x square plus 2x plus 1. See, this is what is the required polynomial, right? So you can answer this problem in this way also, but you will have to remember what is the logic behind. Then you can answer whatever that hard problem also very easily, right? So moving on to the next problem here. The next problem is alpha and beta are zeros of the polynomial x square minus 6x plus k. Find the value of k if 3 alpha plus 2 beta is equal to 20. Okay. So I will write here alpha comma beta are zeros of x square minus 6x plus k. Then immediately you will have to write what is alpha plus beta. So alpha plus beta is equal to minus b by a, which is equal to minus b is minus 6 by a is equal to 1, which is going to be 6. And what is alpha into beta? Alpha into beta is equal to c by a, c is equal to c by a, where c is equal to 1 divided by, k divided by 1 is equal to k. And what is the another information given here? 3 alpha plus 2 beta is equal to 20. So how do I use that 3 alpha plus 2 beta is equal to 20? 3 alpha plus 2 beta is equal to 20. See, if I think logically here, 3 alpha plus 2 beta is equal to 20, then I think I can get one idea here. That is, I am writing this 3 alpha as, or else you can even use this information also. Alpha plus beta is equal to 6. Then from this, what is the value of alpha? Alpha is equal to 6 minus beta. So if you write 6 minus beta here in the place of alpha, so 3 into 6 minus beta plus 2 beta is equal to 20. Then 3 into 6 equal to 18 minus 3 beta plus 2 beta is equal to 20. Then minus 3 beta plus 2 beta is equal to only 1 beta is equal to 20. So 18 minus 20 is equal to beta. So 18 minus 20 equal to beta means beta is equal to, how much is this? Beta is equal to minus 2. So I got the value of beta, right? After getting the value of beta, how do I get the value of alpha? It is already here. So alpha is equal to 6 minus beta. Beta is equal to minus 2. So minus of minus 2. Therefore the value of alpha is equal to 8. So I got the values of alpha and beta. So what do I want now? I want the value of k. So since k is over here, since alpha into beta is equal to k, the value of alpha is 8 and beta is equal to minus 2 is equal to k. So that 8 into minus 2 is equal to minus 16 is the value of k. So this way we can answer this problem easily. Next, if p and q are zeros of the polynomial t square minus 4t plus 3, then show that 1 by p plus 1 by q minus 2pq plus 14 by 3 is equal to 0. See, when two zeros are given, I already told you, if alpha and beta are zeros of the polynomial, please don't try to find out the value of alpha and beta individually. There is no use of finding them. Here, p and q are zeros of the polynomial t square minus 4t plus 3. Of course, if you find out zeros, you will definitely get zeros of the polynomial, but it is not required. What is the formula for p plus q? So p plus q is equal to minus b by a, right? So which is equal to minus b is minus 4 divided by a equal to 1, which is equal to 4. And p into q is equal to c by a. The value of c is equal to 3 by 1, which is equal to 3. Okay? So p plus q is equal to 4 and p into q is equal to 3. After getting that, you need to find out the value of 1 by p plus 1 by q minus 2pq plus 14 by 3. Right? First of all, simplify what is 1 by p plus 1 by q. 1 by p plus 1 by q is going to be p plus q by pq minus 2pq plus 14 divided by 3. I think you know the values of p plus q and p into q, right? P plus q is equal to 4 divided by p into q is equal to 3 minus 2 into pq is equal to 2 into 3 plus 14 by 3. Okay? When you simplify them both, see the LCM is 3. 3 cancel, remaining 4 minus 3 3s are 9, 9 2s are 18 plus 14 by 3 is 14 by 3. See here, 4 minus 18 is equal to minus 14. So minus 14 by 3 and plus 14 by 3, which is equal to how much? Is equal to 0. That is what is the way of answering the problem. This is the systematic way to answer the problem. But if you observe this, problem can be done in another way also. What is that another way? The given polynomial p of t is t square. The polynomial here is t square minus 4t plus 3. Right? T square minus 4t plus 3. Here we can factorize this because 3 into 1 equal to 3. 3 plus 1 is equal to 4. Right? So you can write this one as t minus 1 into t minus 3. So t minus 1 into t minus 3 means the values of t are 1 comma 3. They are zeros which are p comma q. So p is equal to 1, q is equal to 2. You can substitute them easily. 1 by p plus 1 by q minus 2pq plus 14 by 3. When you substitute them here, p is equal to 1, so 1 by 1 plus 1 by q is equal to 3 minus 2 into pq is nothing but 1 into 3 is equal to 3 plus of course 14 by 3. Okay? 1 plus 1 by 3 is equal to 4 by 3 or 2 3s are 6, right? So here it is 1 by 3 minus, this is 1 minus 6 is equal to minus 5 by 1 plus 14 by 3. 1 1s are 1 minus 3 5s are 15 divided by 3 plus 14 by 3. See, minus 14 by 3 plus 14 by 3 gets cancelled equal to 0. But see, this method is not applicable all the time. Here t square minus 4t plus 3 can be factorized. That's why we found the factors. Of course, we are done with the problem. But most of the times, majority of the times, that factorization cannot be possible. So that is why you will have to depend on this systematic way of answering the problem. Right? Moving on to the next problem. If the sum of zeros of the polynomial 5x square minus 3 plus k into x plus 7 is 0, Then find the zeros of the polynomial. See, there are two polynomials given. What is the first polynomial? Let us consider the first polynomial as p of x. That is going to be 5x square minus of 3 plus k times x plus 7. Given that sum of the zeros of the polynomial is 0. So sum of the zeros is 0 means alpha plus beta given as 0. Alpha plus beta is equal to 0. Alpha plus beta means what? Minus b by a is equal to 0. Find out what is minus b by a here. Minus b is minus of 3 plus k. So minus of 3 plus k. See, minus b by a is equal to 0 means minus b is equal to 0 only. Minus b is equal to 0 means b is equal to 0. Of course, you can use this information. But I am directly finding this. Minus of minus b by a is equal to 5, which is equal to 0. So finally, minus of minus plus and 3 plus k is equal to 0. Because 5 into 0 is equal to 0. If 3 plus k is equal to 0, then the value of k is equal to how much? It is going to be negative 3. After finding out the value of k, you need to find zeros of this polynomial. Why to find zeros of this polynomial? What is the relationship between this one and that polynomial? See, you can find k here. If you will be able to find the value of k by using that first equation, first polynomial, then only you can substitute that in the second polynomial, right? That is why the first polynomial is given. And second polynomial, for example, g of x. That g of x is here 2x square minus 2 into k plus 11 times x plus 30. Correct? Substitute k is equal to minus 3. So it would be 2x square minus 2 into minus 3 plus 11 times x plus 30. So 2x square minus 11 minus 3 is equal to 8. That is plus 8. 8 2s are 16 into x plus 30. See, I think you can take 2 common here. Then it would be 2 times x square minus 2 8s are 16 plus 2 15s are 30. Okay. So in order to find the factors of this polynomial, 15 1s are 15, 5 3s are 15. So 2 times 5 3s are means x minus 3 into x minus 5. So these are the factors of the polynomial. So then what are the zeros of the polynomial? In order to find zeros of the polynomial, equate with 0, and the values of x are x minus 3 equal to 0, then x is equal to 3, x minus 5 is equal to 0, x is equal to 5. So 3 comma 5 are zeros of the second polynomial. Understand? Right. Moving on to the next problem. If one zero of the polynomial a square plus 9 times x square plus 13x plus 6a is reciprocal of the other, find the value of a. One zero is reciprocal of the other. Let me take the given polynomial as p of x. That is a square plus 9 times x square plus 13x plus 6a. Okay, that is the polynomial. But what is the information given? One zero is reciprocal of the other. One zero is reciprocal of the other means alpha is equal to alpha only. Then beta is equal to what? Reciprocal of the other means it would be 1 by alpha. Correct? So 1 0 is alpha, another 0 is 1 by alpha. Then you have two informations. They are alpha plus beta and alpha into beta, right? So which is the preferable one to identify the value of a here? If you go by alpha plus beta, then alpha is alpha, beta is 1 by alpha. Then alpha plus 1 by alpha is equal to minus b by a. That is 13 divided by a square plus 9. Again, you are getting two unknowns. They are alpha is one unknown and a is one more unknown. And second information is alpha into beta is equal to c by a. Alpha is alpha, beta is 1 by alpha. Then alpha into beta will become alpha into 1 by alpha. So alpha into 1 by alpha will become 1. There is no variable. So then that is the right way of choosing the information. Okay. So consider the product of zeros. Consider product of zeros is alpha into beta, which is equal to c by a, where alpha is alpha and beta is 1 by alpha is equal to c is 6a divided by a is equal to a square plus 9. Now alpha and alpha gets cancelled. then this is 1 is equal to 6a by a square plus 9. By cross multiplication, a square plus 9 is equal to 6a. Okay. Now transpose 6a this side. A square minus 6a plus 9 is equal to 0. I think this is a perfect square. What is that square? A minus 3 whole square is equal to 0. A minus 3 whole square is equal to 0 means a minus 3 equal to 0, then the value of a is equal to 3. This is the best and easiest way to answer this problem. But this problem can be answered in another way also. Suppose this problem is given for 1 mark questions. Can be given for 1 mark questions also. If 1 0 is the reciprocal of the other, for example, p of x is like ax square plus bx plus c. 1 0 is reciprocal of the other. Then that equation will be p of 1 by x, because 1 by x is the reciprocal of x, right? So when you substitute 1 by x in the place of x, then it will become a into x square is 1 by x whole square, that is x square, plus b into 1 by x is 1 by x, plus x is 1 by x, right? And c is c only. If you take LCM, then LCM is x square, and here it is a plus bx plus cx square. Then finally, p of 1 by x will become 1 by x square times cx square plus bx plus a. So it means, if you have an information that 1 0 is the reciprocal of the other, then see here, these two places are being interchanged. Means a becomes c and c become a with this. But b remains unchanged. So that if you have this information, if 1 0 is the reciprocal of the other, simply you go by a is equal to c. When a and c both are equal, then only 1 0 is reciprocal of the other. See now, a is equal to c. What is a here? A square plus 9 equal to c is 6a. We got that only here. A square plus 9 is equal to 6a. If you can utilize this information, then you can start solving the problem from here itself. You don't have to do all these things. Got it? Fine. So moving on to the next problem. Here, prove that the number 3 power 13 minus 3 power 10 is divisible by 2, 3 and 13 also. How is this possible? How to solve this? And how to prove that this number is divisible by 2, 3 and 13. 3 power 13 is a very much bigger number. Will you be able to find what is 3 power 13? 3 into 3 into 3 and so on, multiplied by 3 itself 13 times. Like that 10 times. But if you use your brain properly, the given number here, for example, I am writing the given number as n. n equal to 3 power 13 minus 3 power 10. Okay? See, both the bases are 3. Powers are different. So 3 power 13 is bigger than 3 power 10. We know that. How much bigger? That is what? 3 power 13, I am writing it as 3 power 3 into 3 power 10. Can we write like that? Since the bases are equal, power should be added. 3 plus 10 is equal to 13. Again, you are getting that. Minus 3 power 10 is 3 power 10. So, will you take 3 power 10 common from both the two terms? Yes, 3 power 10 times 3 cube minus 1. So, that is 3 power 10 into what is 3 cube? 27. 27 minus 1 equal to 26. Now, you see, this is more simpler. And here you can write it as 3 power 10 into 26 is 2 into 13. Now tell me, what are the factors of this number? 2 is one factor, 3 is one factor, 13 is one factor. So therefore, this number has 2, 3 and 13 are factors. So this is the way of answering the problem easily. Okay. So this is what is about the problems given for 3 marks. All problems are very simple. Again, we are going with the same logic. Remember, what is sum of zeros, what is product of zeros. You can easily crack these problems. Hope you understand, enjoy the class. Thank you.